we would like to determine the pH based on the dyes that we have here. We have A, E, B, and C horizons, and we would like to determine the pH of these 4 horizons based on the dyes. What you need to do is first you need to get a spot plate and then add a small amount of soil here in each of these spots, and then you will use these 3 indicators. The broom thymal blue is used for more toward basic pH. The broom crystal green is used for more acidic pH, and then this is the intermediate pH. So if you have no idea what the pH of your soil is, and then you can start with the red dye, and then if needs to be, then you can move to those other dyes. So what I already did, so just for the sake of time, I already add these red dyes to these 4 horizons, and you can see that there is charts that you can compare these with the reading. So what we have right now here is that the first horizon is out of the order or out of this chart, so we will need to use a different indicator. So this is 6.4 pH, so this is higher than 6.4, so therefore we will use the blue indicator for that one. And similarly for the C, we're out of the chart, so we will also use a blue indicator for that one. But for these 2 middle ones, we can use the readings from based on this chart. So the color for the E horizon is matching with the pH of 5.2, and then the color for the B horizon is matching around like 5.8 kind of, so between these 2 color. So that's how you determine the pH based on the indicator dye. So I will show you, since we are out of the limit for the red color or the red dye, we will try to use the blue because we will move toward more basic ones. And you just add a small amount of the dye to your soil, so that will just cover up, and then you swirl this for a few seconds. And then based on the colors, then you can again determine the pH. So the top color, this indicator, this color chart will be used for both indicators. For the bottom part will be used for the green indicator. It's more acidic ones, and then the top one will be used for the blue color or the blue dye, and those are more basic ones. So as you can see here, the pH of the A horizon is matching like around kind of 7ish, and then the color for the C horizon is more like dark green, and that will be 7.4 pH. So these are like how you determine the pH of a soil based on the indicator dye. And as I said, so you always start with the red dye if you don't have any idea about, like, the general idea about your pH of a soil, then you can move with these 2 other dyes. In this station, we will also like to determine the pH, but this time with more accurate methods. So what we need to do is prepare our sample first. We need to follow a few steps. What you need to do is take a cup, and then you need to add soil into that, a spoon of soil, so into this cup, and then you add 20 milliliter of DI water. So the deionized water, you need to get 20 milliliters and then add it to the cup. So I just prepare one sample here, and then you stir that sample, and then leave it for 5 minutes so that all the nutrients and stuff will get out of into the solution. And then we will usually have this in the solution. So usually the electrode will be in the solution. You need to clean this every time so that you will not have misreading. So this will be in the solution, and then put this in the standby mode. So, and then you get it out of the solution. Rinse it again. And then lower that into your soil solution, and then stir this, and then push the pH button twice, So the pH for the soil is somewhere between 5.9. So as you can see, maybe the reading here, so it's 5.9 pH. And again, you can add that plus and minus 0.2 to this, so that will be the range. The next step that we determine the pH right now, this is, as I said, more accurate method than the dye method that we used before. But this time we also add one more thing. If the goal is to increase the pH of a soil from 5.9 to 6.5, which is the kind of basic, basically the neutral pH area that most of the nutrients will be available to the plants. So in that case, we need to add lime to increase the pH of the soil. So, but before we need to determine the amount of lime, we need to determine the texture of the soil and also determine the color of the soil. So based on those two pieces of information in the pH, we should be able to determine how much lime do we need to add to raise the pH of the soil to 6.5. So first thing that you need is, beside the pH, is the texture. So based on the texture, it's very soft and smooth. So I'm in the silt side, and it doesn't make a long ribbon. So it's just like very soft. It's more like silt loam soil, and the ribbons are not sticky, or the soil is not sticky, and the ribbons are not long. So you can see that its break, the natural breaks are like less than 1 inch. So that tells me that the soil is a silt loam soil. And then if I determine the color, the colors are matching at the 10YR34 color. So this is a light color soil. So we are in the light color soil, and then the texture is silt loam. So we are in the second category or second line. In our current pH is 6, close to 6, I will say. So the goal is to increase the pH to 6.5. So we need to add 1/10 of lime per acre to increase the pH of this current soil from 5.9 or close to 6 to 6.5. So that's how you determine the lime application based on those three pieces of information. In this station, we would like to talk about the quality of lime in its satisfactory level in Indiana state. So in order for a lime to be considered satisfactory in terms of quality, 80% needs to pass through the 8 mesh. So this is the 8 mesh sieve. So it has 8 openings per inch. And then 25% needs to pass through the 60 mesh, which has 60 holes per inch, and then, or openings per inch. And then so that will be how we will determine the quality of lime. So we had 1,000 gram of lime, and we added through this 8 mesh first, and then out of that 1,950 went through this 8 mesh, and then only 50 just stayed on top. So in that case, the criteria that we will have 95%, so 950 divided by 1,000 times 100 will be 95%. So we already met one criteria, which is the 80% for 8 mesh. And then the second criteria is that 25%. So let's see that how much it went through. So out of that 950 right now, 636 stayed on the 60 mesh, and then 314 went through. So 314 went through this. This will be the 314 gram that we have. So 314 divided by 1,000 times 100 will be 31.4%. So we met the second criteria also, which is the 25% limit for 60 mesh. And we have right now 31.4%. So based on those two criteria, we met the criteria for the Indiana satisfactory level. So yes, we can apply this lime. The reason that we are targeting for the finer lime, the finer the lime, the better they will react into the soil, and then the faster they will react, and that's how the pH will start changing. These are not really quality ones. If you apply that one, it takes so much longer to start showing their effects.